Hi everyone, today we'll see what is IoT Edge and the key elements of IoT Edge. IoT Edge moves cloud analytics and custom business logic to devices. That is, IoT Edge pushes the relevant cloud software to your IoT device where the data already resides. We know that billions of devices that make up the Internet of Things resides not in the cloud but on the premises. You can take right from the wind farms to factory floors. All the devices have sensors on the equipment that collect the telemetry data, video, and many other types of data. Because of the huge volume of the collected data, it has become very difficult and impractical to constantly upload all of the collected data to the cloud for processing and analysis. And here comes the IoT Edge, which frees you from the need to upload your device's data to the cloud whenever you want to run the cloud-based apps on it. IoT Edge takes the cloud's functionality and runs it right on the IoT devices themselves. However, in such situations, there is still an interaction between the device and the cloud, but it is a lightweight interaction, primarily used for machine learning purposes. Most importantly, it's no longer necessary to do the heavy lifting involved in uploading all your IoT devices' data to the cloud before you can extract an insight from it. Further, IoT Edge makes it possible for any enterprise to run the cloud-based IoT and AI-related software directly on their IoT devices even when they're offline. In order to understand how IoT Edge works, it is important to look into the details of the three key elements. IoT Edge modules are deployed to IoT Edge devices and execute locally on those devices. These modules are containers that run services which may be third-party services or your own code. IoT Edge Runtime runs on each IoT Edge device and manages the modules deployed to each device. A cloud-based interface enables you to remotely monitor and manage the IoT Edge devices. IoT Edge modules are units of execution implemented as Docker-compatible containers that run the business logic at the edge where they run software to process the data that the device had collected. Multiple modules can be configured to communicate with each other, creating a pipeline of data processing. The software performing the data processing can be your own, or it can be from a service provider or from a third-party app. Regardless of the type of software, Edge modules help to run the workloads directly on your device without relying on a cloud connection. You can also develop custom modules that provide insights offline and at the edge. To deploy your own code to your devices, IoT Edge supports both Linux and Windows so that you can code to the platform of your choice. It also supports Java, .NET, C, Python and many more so that the developers can write codes in a language they already know and use the existing business logic. Further, IoT Edge allows you to deploy complex event processing, machine learning, image recognition, and other high-value AI without writing it in-house. IoT Edge Runtime enables custom and cloud logic on IoT Edge devices. It performs a number of functions which includes monitoring and managing the device and facilitating communication between the modules, devices, and the cloud. The runtime supports both Linux and Windows operating systems. The other functions of runtime includes installing and updating workloads on the device, maintaining IoT Edge security standards on the device, ensuring that IoT Edge modules are always running, and reporting module health to the cloud for remote monitoring. The most important function is greasing the wheels of communication between your device and the cloud, your device and other downstream leaf devices, and your device's various modules. IoT runtime is often used to deploy artificial intelligence to gateway devices which aggregate and process data from other on-premise devices. But this deployment model is just one option. Further, IoT Edge Runtime runs on a large set of IoT devices that enables using it in a wide variety of ways. That is, you can use a device smaller than a Raspberry Pi if you are not processing more data. And you can use an industrial server to run resource-intensive workloads. Fundamentally, it is difficult to manage the software lifecycle for millions of IoT devices because they are of different makes and models and are geographically scattered. Workloads are created and configured for a particular type of device deployed to all of your devices and monitored to catch any misbehaving devices. These activities can't be done on a per device basis and must be done at scale. The IoT Edge Cloud interface serves as a control center for IoT Edge. The cloud interface leverages IoT solution accelerators to make it far easier to create workloads to push to your IoT device, which IoT Edge can then apply directly to the data that your device collects. You can also monitor all the workloads that your devices are running from the cloud interface. IoT Edge effortlessly integrates with IoT solution accelerators to provide one control plane for your solution's need. Further, cloud services allow you to create and configure a workload to be run on a specific type of device, send a workload to a set of devices, and monitor workloads running on the devices in the field. Thank you for watching this video. If you find this video to be useful, kindly subscribe it and share it with your friends.